Alright, today we're talking about 5.2, which are the sum and difference identities. So we're going to be learning 6 new trig identities. And what we're going to do with them is we're going to find some exact values of trig functions. So just like we've been doing over the last 2 chapters, we're going to show some trig statements are true against more like identities and proving identities. And lastly, we're going to be simplifying trig statements. So we're just going to try to make them in as simplest form as we can. So these are the 6 trig functions we're learning about today. 2 for cosine, 2 for sine, and 2 for tangent, a sum and difference for both. Now we'll be referring to these all lesson, so don't need to memorize them this slide, but you are going to want to memorize these. You want to know these. So let's start with the sine of 75 degrees. Now if we come back to our identities, right, I have 2 to choose from for sine, a sum or a difference. So what I need to do is I need to come up with 2 angles that add up to 75 degrees, but that also have some special triangle capabilities, some special triangle identities that I may know. Well, I can write sine of 75 as a sine of 30 plus 45. I chose those, they add up to 75, and I also know some special triangle things about them. So let's use my identity now. My identity is the sum sine, so it's sine A cosine B plus cosine A sine B, and write that out. So I'm going to let A be my 30 degrees, that's my first angle, and B is going to be 45, my second angle. So I can rewrite this out as the sine of A, which is the sine of 30 degrees, the cosine of 45 degrees, cosine B, plus cosine of A, which is 30 degrees, sine of B, or 45 degrees. Now, I know each of those based on special triangles. I know that the sine of 30 is 1/2. I know that the cosine of 45 is root 2 over 2. Plus, I know the cosine of 30 is square root 3 over 2. And lastly, I know that the sine of 45 is root 2 over 2. Now I'm going to multiply this out. Remember, when I multiply fractions, I multiply numerators, multiply denominators. This is root 2 over 4 plus root 3 times root 2. Well, that's root 6 over 4. And lastly, put them into one fraction. I got to make it as simple as possible. Root 2 plus root 6 all over 4. That's my answer. That's as simple as it gets. Let's try one more. The cosine of 7 pi over 12. Now, if you can see this in radians, that's awesome. Do the whole thing in radians. However, if you can't see this in radians, or you think better in degrees, you can switch it. So you can use my conversion factor, 180 over pi. My pi's cancel. I end up with 105 degrees. So we can also write this as the cosine of 105. Now, I have 2 cosine identities, an addition and a subtraction. So I got to come up with 2 angles that have special triangle capabilities with them that add up to 105. Well, I can rewrite this as the cosine of 60 degrees plus 45 degrees. They're special triangle degrees, and they add up to 105. Make a line so I don't get too crossed up. Using my identity, it's a cosine addition. So I'm using this first one, cosine A cosine B minus sine A sine B. What's A and what's B here? Well, my A is going to be my first angle, 60 degrees. B is 45. Hopefully if my pen writes. There we go. Okay, let's break it apart. Cosine A, or cosine 60, cosine 45, that's my B angle, minus, with cosine they're opposite, so if it's an addition, we subtract them. If it's a subtraction, we add them. Sine 60 degrees, sine 45. So literally just plugging in my angles into my identity. Now I know each of these 4. Cosine 60 is 1/2, times cosine 45 is root 2 over 2, minus sine of 60 is square root 3 over 2, times square root 2 over 2. Now I'm multiplying fractions, multiply numerator, multiply denominator, so I get root 2 over 4 minus root 6 over 4, or when I make them one fraction, root 2 minus root 6, all divided by 4. And that's my final answer. So let's prove some identities. I want to show that the cosine of x plus 2 pi is equal to the cosine of x. In other words, this 2 pi doesn't do anything. Remember, it's an identity, so I've got to draw my vertical line, and I cannot touch the right side. So this is a cosine addition, or a cosine sum. So I need to write it out in terms of the cosine addition, which is cosine A, cosine B, minus sine A, sine B. Well, what's A and what's B here? Well, my first angle is x. So x is going to be A. That's my A angle. And my 2 pi, that's going to be my B angle. So let's just plug those two things into my identity. So this becomes the cosine of A, or cosine of x, cosine of B, or cosine of 2 pi, minus sine of A, which is x, sine of B, which is 2 pi. Now let's see what I can do here. I cannot do anything with this cosine x, so that just has to stay there. Cosine x. Let's think about cosine 2 pi. Come back to my unit circle. 2 pi is right here. What's the x value there? 1. So times 1. Minus. Cannot do anything with sine x, but let's think about the sine of 2 pi. What's the y value here? Just 0. So this simplifies down to cosine x, which is my right-hand side. Smiley face to say we're done. Alright, let's do another one. I want to show that the tangent of x minus pi over 4 is equal to tangent x minus 1 over tangent x plus 1. Again, draw my vertical line. Now, we want to come back to my tangent formulas. We haven't talked about these yet. I have two of them, an addition and a subtraction. Now, I had the addition one on my slide, my problem that I'm doing, so I'm going to use this first one here. That's the tangent of A plus B equals tangent A plus tangent B, all divided by 1 minus tangent A, don't say tan A, tangent A, tangent B. So I'll rewrite that on this page here. Tangent A plus B is equal to tangent A minus tangent B, all divided by 1 plus tangent A, tangent B. So let's figure out what A and B are. A is this x value again, B is pi over 4. So let's just plug in what I know into my formula. So the left-hand side becomes tangent A, which is tangent x, minus tangent B, which is tangent of pi over 4. All divided by 1 plus tangent A, or tangent x, tangent pi over 4. Now if we think to my special triangles here, with a pi over 4 angle, my side lengths are 1, 1, square root 2. So what is tangent of pi over 4? Well, that's just opposite over adjacent, or 1. So we can think of this as tangent x minus 1 divided by 1 plus tangent x times tangent pi over 4 again is just 1. Now notice we have a tangent x minus 1 divided by 1 plus tangent x. Well, the bottom isn't quite right, but remember with addition I can add in any order. So I can swap around this denominator here. So I get tangent x minus 1 in my numerator divided by tangent x plus 1. Smiley face, we are done. So let's go the opposite way. I know the expanded form. I know the expanded identity here. But I want to write it as a single trig function. So instead of going from a single trig function to the expanded form, I'm going to go the opposite way. So notice right away, I have a cosine 3x cosine 2x minus sine 3x sine 2x. So I have a cosine cosine minus sine sine. Hopefully that should look familiar as my cosine addition identity, or cosine sum. So to write that out, cosine of A plus B is equal to cosine A cosine B minus sine A sine B, which looks pretty familiar to my problem. So let's figure out what A and B are. Well, A is my first angle in my first cosine, so 3x. B is my second angle in my second cosine, so 2x. So this whole identity here, this whole equation or expression becomes cosine. My A is 3x plus my B is 2x, or cosine 5x. And that's my single cosine. Let's do the same thing again. Sine 5x cosine 2x plus cosine 5x sine 2x. Again, I have a sine cosine plus cosine sine. Hopefully that should look kind of familiar to my sine addition. Let's write that out. Sine of A plus B is equal to sine A cosine B minus, plus, I apologize, I've written these backwards. This should be the sine difference, my apologies. The sine difference identity is sine A cosine B plus their opposites, cosine A sine B, at the very end there. So let's figure out what A and B are. Well, A is my first angle, so 5x. B is going to be my second angle, 2x. So let's plug in what I know. This is sine of my A value is 5x minus my B value is 2x, and I get the sine of 3x. Nope, I had it right the first time, didn't I? I apologize, folks. This should be a plus here. My brain is a little tired this morning. My apologies. This should be the sine of 5x plus 2x. My apologies on that. So my final answer will be the sine of 7x. My apologies on that. I had my identities a little backwards. So to recap, to kind of clear up my mistake, this should be the sine of A plus B. The signs stay the same on the sine identities. So we get the sine of 5x plus 2x, or the sine of 7x. Again, I had made a mistake. My apologies on that. Let's go to the next one. So if I have the sine of A is 3/5 with A in quadrant 1 and cosine B is negative 5/13 in quadrant 3, apologies. We need to find the sine of A plus B. So right away I'm going to use this sine A is equal to fraction, cosine B equals the fraction. I'm going to draw some triangles. So let's start with A. A is in quadrant 1. Draw my A. And I know that the sine of A is 3/5. So the opposite is 3, and the hypotenuse is 5. Hopefully you can recognize that as a Pythagorean triple. If not, use Pythagorean theorem. We get that this is 4. Lastly, cosine B is negative 5/13 in quadrant 3. So I'm in quadrant 3 now. Angle B. Now the cosine is negative 5/13. So my adjacent is negative 5 and my hypotenuse is 13. Again, Pythagorean triple, this is negative 12. Now using my identities, my sine sum, I know that the sine sum is going to equal sine A cosine B plus cosine A sine B. Let's think about these different angles. What's the sine of A? Well, that's just opposite over hypotenuse, or 3/5. Times, what's the cosine of B? Well, that's just the adjacent over hypotenuse, or negative 5/13. Plus cosine of A, adjacent over hypotenuse, 4/5. Times sine B, that's just negative 12 over negative 5, or a positive, my apologies, negative 12 over 13 hypotenuse. I had my hypotenuse mixed up. So it's a negative 12 over 13. So when we simplify this down, we end up getting negative 3/13 for that first term, minus 48 over 65, or final simplifying, negative 63 over 65. That's the sine of A plus B. Now let's do another one, the cosine of A minus B. Again, I'm using the same triangles. Let's use red here. So I'm going to break this apart using my cosine difference. Well, that's equal to the cosine of A, cosine of B. With cosine, it's opposites. This is a plus, sine A, sine B. Now I'm just going to use my triangles to figure out each term. Cosine of A, 4/5. Cosine of B, negative 5 over 13. We have a plus. What's the sine of A? That's just 3/5. Sine of B, negative 12 over 13. Again, simplifying both terms. My first term is negative 4 over 13. Minus, I have a minus sign here that turns the plus to a minus, 36 over 65. Or very finely simplified, negative 56 over 65. That's my final answer. Hey, let's do one more. Same idea. Sine of A is 3/5, quadrant 1. Cosine of B is negative 5/13, quadrant 3. So my pictures are going to be the same. I'll redraw them here quick. Same triangles though. We have 3/5, 4, and then in quadrant 3 is my B angle, negative 5/13, and negative 12. So that's my same triangles here, just redrawn. Now if we go back to the first slide to look at what the tangent of A minus B is, that identity, I'll rewrite that for us here. That's equal to the tangent of A minus the tangent of B, all divided by 1 plus tangent A, tangent B. So we just need to figure out what the tangent of A and the tangent of B are. Well, that's pretty straightforward. We have my triangles. Let's just figure out what they are. The tangent of A, we get 3/4 minus tangent of B is 12 over 5, all divided by 1 plus tangent of A is 3/4 times tangent of B is 12 over 5. Okay, so I want to simplify the numerator and the denominator into two fractions, so there's going to be a fraction in both numerator and denominator, and then I'm going to flip them, reciprocate the bottom one so that I can multiply them. So I'm going to make a common denominator of 20 in my numerator and in the denominator as well, so I can combine them. So when I do that, my numerator becomes 15 over 20 minus 48 over 20, all divided by, this 1 will become 20 over 20. When I multiply this fraction out, I end up getting plus 36 over 20. Okay, that numerator becomes negative 33 over 20, all divided by 56 over 20. Notice my 20s cancel here. And my final answer, let's write it in, oh, let's go with green. Oh, you cannot see that at all, can you? Let's go purple. Stick with purple. I get negative 33 over 56 as my final answer. Alright, so go ahead and write your summary and any questions you have. Please take a look at this assignment. Do some practice problems on your own before class tomorrow. And then we'll talk about it and hopefully answer some more questions you may have.